In this tutorial, we're going to be talking about how to conduct an independent samples t-test. In the previous tutorial, we talked about how to conduct a one sample t-test where we've got a single sample that we're comparing to a known population mean. So we're going to expand on that a bit, keep a lot of the same ideas, but now instead of comparing a single sample to a known mean, we're going to be comparing two completely independent sample means. We're going to be working with the data set linked in the description below. I highly encourage you to follow along with that so that you can work through the steps in Jamovi at the same time that I am. But we've got an example research question to ground us today. So we're going to be thinking about, do students' heart rate, we're going to measure that in beats per minute, do those heart rates differ if the students are given a pop quiz compared to students who are just going about their traditional classroom assignments? So those are the variables that we're going to be playing around with. That's the question that we're going to be working with. And we're going to cover three main key things about independent samples t-test in this video. So we're going to be covering the assumptions of the independent samples t-test. We're going to be covering how to analyze the independent samples t-test, and then also how to interpret the results and the output that you get from Jamovi. So if you have questions as you're working through this, you can leave them in the comments below. You can reach out to me. My website is ajoytoteach.com, so you can always reach out to me there as well if you want to learn more about statistics or other educational things and how we can work together. All right, so let's begin. So first we're going to define our variables. And again, in Jamovi, we're going to be working with two variables. So our dependent variable is going to be student heart rate that's measured in beats per minute. This is our outcome. We're expecting it to change depending on whether the students are in the pop quiz group or in the traditional classwork group. And that brings me to our next variable, our independent or our grouping variable, which is going to be the classroom condition. So students are either going to be assigned to the pop quiz group or to the traditional classroom assignment group. So before we run an analysis in Jamovi for an independent samples t-test, we need to make sure that we have met three key assumptions so that we can trust the results of the analysis. So that first and one of the most important assumptions of an independent samples t-test is that of independence. So we want for the data points in each group to be independent from each other and from the data points in the other group. However, this assumption is typically addressed in the data collection and research design phase, not as much once we've got the data and we're in Jamovi. So I want you to be aware of it and to know about it, but that's not something that we're going to be checking within Jamovi itself today. What we are going to be checking is the two other key assumptions. That's the assumption of normality. So the assumption of normality states that our dependent variable is normally distributed in a population. So we want to have that nice, pretty normal curve for our dependent variable. We assess this using the Shapiro-Wilk test, and that test will give us back a p-value. Now, normally when we get small p-values that are less than 0.05, we think, oh yay, we found statistical significance. But our view on that looks a little bit different when we're testing assumptions, because essentially what we're doing is we're saying, hey, Jamovi, does the distribution of my sample data, does that differ significantly from the ideal normal data? So if Jamovi comes back and gives us a statistically significant p-value, a small p-value, a p-value less than 0.05, then that tells us, hey, your data is significantly different in normality compared to what would be ideal. So when we are testing assumptions in Jamovi, we do not want p-values that are less than 0.05. We want our p-values to be greater than 0.05 to indicate that that assumption is met. So we've got the assumption of normality, and then we also have the assumption of homogeneity of variance. This assumption is also comparing the spread of the data, the variability of the two groups, trying to ensure that the variances from those two groups are similar to one another. So again, if Jamovi comes back and says, hey, statistically significant p-value, that tells us, our two variances, they differ too much from each other away from what would be ideal, and we haven't met that assumption. So in order to test those in Jamovi, what you're going to do is you're going to go to Analyze and then T-Test, and then select the Independent Samples T-Test. You're going to make sure that you have heart rate selected as your dependent variable, and you're going to make sure that you have classroom condition selected as your independent or your grouping variable. So there's going to be a lot of options that you'll see. And right now, because we're looking at the assumptions, I want you to select the boxes for testing normality and testing homogeneity of variance. So again, as I mentioned, the key thing that we're going to be looking for here is the size of the p-value associated with those two tests. So if we look at our Shapiro-Wilk test, we've got a p-value coming back that is 0.3. 0.3 is larger than 0.05, so we are in the clear. We have not violated the assumption. Our data appears to be normally distributed. So that's wonderful. We're good to go. And now we can take a look at the homogeneity of variance assumption from Levene's test. So again, we've got a p-value that is well above 0.05, a p-value that is 0.926. Excellent, wonderful. This tells us that we have not violated the assumption of homogeneity of variance. Now, let's talk about what would happen if we had violated one of these assumptions. So for normality, there's a saying, t-tests are robust to violations of normality, meaning that they can kind of take a hit. If we violate normality, that doesn't automatically mean we have to throw everything out and that we can't trust any of our results, but it does mean that we want to be mindful. I always recommend taking a look at the histogram of your variables, taking a look at plots to see if you violated normality, potentially what might be going on, or your data skewed, something along those lines. And also you want to be mindful of your sample size. So the larger our sample size, the less we need to worry about violations of normality. Rule of thumb is that if our sample size is above 30, that means we have less to worry about when it comes to violations of normality. Now, thinking about violations of homogeneity of variance, Jamovi makes this even more simple for us. If we had violated the homogeneity of variance assumption, we could instead use the Welch's t-test, which is just a click of a button in Jamovi, and that adjusts for the differences in the variances. Now, let's imagine that you are very concerned. You want to be more on the conservative side, making sure that you can really trust your results, and you violated normality and you violated homogeneity of variance. In that instance, you can instead run a non-parametric version of the independent samples t-test. Now, that's beyond the scope of this particular video, but if you'd like more information on that, I'm happy to make a tutorial explaining that further. Just let me know in the comments or reach out. So once the assumptions are checked, then we can proceed with the analysis. So again, make sure that you've got heart rate set as the dependent variable and classroom condition as the independent variable. And I'm going to have you select a couple more options here. So I want you to select the mean difference. I want you to select the confidence intervals for the mean difference, select the effect size, Cohen's D, and then also the descriptive statistics. Now I'm going to walk through those with you and help you to interpret the results. First, let's start with the test statistic and the associated p-value. So the test statistic that we have here is a value of t, and the results say that our t-value is -7.13. So by itself, we don't get as much information from the test statistic alone. What helps us to interpret that test statistic is the associated p-value. Here, our p-value is less than 0.001, which is of course less than 0.05, indicating that the difference between the heart rates in these two groups is statistically significant. That means we can reject the null hypothesis. But statistical significance all by itself is important and it can be interesting, but it doesn't give us a full picture of what's happening with our data. That's why I wanted you to select some of that other output. So let's take a look now at the mean difference. This is one of my favorite metrics because it can really help us get our heads around what the actual potentially practical difference is between the two groups. We know that they're significantly different, but maybe we want to know a little bit more than that to fully understand. So the mean difference here is -11.8, or we can maybe round that to 12. So what this is telling us is that the average difference between people in the pop quiz group and people in the traditional classroom group is almost 12 beats per minute difference. So there's a difference of 12 beats per minute of your heart rate depending on the group that you're in. That gives us a bit of a better understanding than just statistical significance on its own. Then of course we have the confidence interval to go along with that mean difference. This helps us to provide an idea about the variability and the range of where that estimate might lie in the capital T truth world, right? So anytime that we're conducting analyses, we know that there's going to be error associated with it because these are based on samples and they're imperfect, all that good stuff. all the bad stuff. So we have our estimate that the difference is around 12 beats per minute, but that the confidence interval gives us a range to say, that is just an estimate, but we are pretty sure that the difference exists somewhere between, in this situation, 15 beats per minute to 8.5 beats per minute. Next, I want you to take a look at the effect size. So the effect size tells us more about the magnitude of the difference between the two groups, and it goes along really nicely with that mean difference. So for independent samples t-test, we view the effect size in Cohen's d terms, which is a standardized mean difference effect size, and Cohen's d is in standard deviation units. So the typical rule of thumb there is that Cohen's d of 0.8 and higher is considered a large effect size, and here we have a value of 1.17. So we know that we have a statistically significant difference. That difference, more specifically, is somewhere around 12 beats per minute, and that value of 12 beats per minute is considered a large difference between the two groups. So all of those pieces together give us a fuller picture than just p-value by itself. Now we can also take a look at descriptive statistics, looking specifically at the averages of the two groups. So we've got the heart rate for the traditional classroom being at around 110 beats per minute, while the pop quiz group is averaging 122 beats per minute. So you can see the difference between 122 and 110 is around 12. So that's where we're getting that mean difference from there. And this also tells us that it's the pop quiz group that has that higher heart rate. So that might make us think, maybe there's something about pop quizzes, maybe they're more stressful or anxiety provoking that is resulting in some higher heart rates for the students that are in that group, potentially. So to summarize what we've learned here, we conducted the independent samples t-test in Jamovi after we verified that the assumptions were indeed met. Then we were able to interpret the results. We found statistical significance and a large effect size. So we know that there is an important difference between the heart rates of these two groups. So thank you so much for watching. Be sure to subscribe if you want more Jamovi tutorials or other educational information in the future, or you can reach out to me either in the comments or through my website to ask more questions or work together further. Bye!